an example on multiple transformations within a parent. So your parent function is y equals the square root of x. So here is your parent. So it's a square root function. Alright, I've done a little bit of work for you on this PDF. I've evaluated some ordered pairs. I substitute 0 into the function, I get 0. Substitute 1 into the function, the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And remember, when you go into the negative values, those don't exist. Alright, now let's go ahead and pull apart the transformation. So let's start with the negative. The negative in front or outside the function is considered a reflection, and it's a reflection about the x-axis. So the first transformation is reflect about the x-axis. So when I think about reflections, I always want to think opposite. So since it's an x-axis reflection, we're going to go to the opposite variable, y, and we're going to change all of those ordered pairs to the opposite sign. So let's go ahead and take care of those first. So opposite sign of 0 is still a 0. There should be a y here. Opposite sign of 1 is negative 1. Opposite sign of 2 is negative 2. Opposite sign of 3 is negative 3. We don't have to graph those two last order pairs because they're not going to exist. All right. The other transformation is a multiplier of 3. A multiplier outside the function, it's in front of the function, is going to affect the vertical axes, your y-axis. And since it's a multiplier greater than 3, or 3 and greater, or greater than 1, it's going to be a stretch. So this is called a vertical stretch by 3. So vertical axis represents your y-axis, so we're multiplying all of these by 3. So 0 times 3 is still 0. Negative 1 times 3 is negative 3. Negative 2 times 3 is negative 6. And then negative 3 times 3 gives us negative 9. So these are going to be your finished y values. Now, did we do anything with your x values? No. So we're going to go ahead and just copy these ordered pairs values. So 0, 1, 4, and 9. All right, we're set to go. So we'll graph this in blue today. So we're going to go over 0, up 0, and then over 1, down 3, and then right 4, down 6, and then over 9, down 9. Oh, I forgot to graph my parent. I better do that. Okay, so our parent is 0, 0, over 1, up 1, over 4, up 2, and then over 9, up 3. So there's your parent. And then the blue function is your new function. Remember, notice that it is reflected about your x-axis. This is your horizontal axis, so it's reflected about that. And then it is stretched on the vertical axis, the y-axis, by a multiplier of 3. Let's go ahead and take a moment and identify this domain and range here for this function in the blue. The domain is what numbers can you plug in for x. And you're noticing that your x values, just like the parent, you can't plug any of those negative numbers in, so your domain is going to be x needs to be greater than or equal to 0. Now your range. The range is a little bit different than your parent function. Notice that all of your y values are happening below this horizontal axis. So we say this is y is less than or equal to 0. Now in our parent function, it's above that horizontal axis, so that would be y greater than or equal to 0. So our parent function's domain, our parent function range and domain is different than our new function. So our range is y is going to be less than or equal to 0. It's below that horizontal axis.